Hello, hi, welcome to Apsana Classes. Today in this video, let's learn about the multiplexers. Before that, a beautiful quote sent by Ashok said, "The whole secret of existence is to have no fear. Never fear what will become of you. Depend on no one, only the moment you reject all help are you freed." So as that, let's be independent and make ourselves a brighter and bold by not depending on anyone. Okay, let's look at the topic. So today's topic is multiplexers. So multiplexer is a combinational logic circuit. As it is a combinational logic circuit, it only depends. The output of the multiplexers depends only upon a present inputs. So what are the inputs to the multiplexers? So input to the multiplexer is a selection lines, not data lines. Okay. So actually, what is multiplexer? Let's see. Multiplexer is also called as mux. Then we have data lines. So multiplexer primarily called as initially called as many to one. The basic logic of the multiplexer is many to one. So we have many data sources from which we are going to get the selected, the particular that we are selected by the selection step. So for example, I have data lines, 4 data lines, then I should give 2 selection lines. Why should I? Because it depends upon a 2 power n. If you see here, in adders, full adder, half adder, everywhere we mostly use this 2 power n relation. Why so? Because here we are using R for binary, where binary is 0 and 1, 2 digits. So we are using 2 power n relation everywhere. So somewhere where it is needed. Okay. So many to 1. Fine. We have data lines D0, D1, D2 and D3. Then I should give the selection lines as S0 and S1. Why should I? Because 2 power n. If we have 2 power n as data lines, then we should give n selection line. Then you will get only one output. That is the basic logic, many to one. So by not wasting the many lines, so we send the information in one line. That is the basic logic. Then let's see how we are going to select D1 by the selection lines. And also let's look at the output equation parallelly. For truth table, from the truth table, you can observe all those. So truth tables is the relation between input and output. So what are the inputs here? Selection lines S0 and S1. So input is S1 and S0. Fine. Then what is the output here? That is a Y, that we get D0, D1 or D2 or D3. Any one we get, but not all. Okay. Okay, fine. If I would like to get D0 as output, what should I select? What should I select? I should select S1 and S0 as 0, 0. If I would like to get D1, then I should select 0, 1 and 1, 0 and 1, 1 for D1, D2, D3 respectively. Well, then what is the equation for each one? So for each one, if you would like to get Y, that is D0 as output, then you should represent the circuit as S1 bar into S0 bar into D0. Okay. What is the S1 here? 0. Then what is the S0? 0. Then if I make it invert, then I'll get 1, 1. So 1 into D0. we get D naught as output. Then you will get a doubt. Okay, if we are making the D1 and D naught as 1 in order to get the D naught as output, if you are making S1 and S0 as 1 1 in order to get the D naught as output, then why should I give 0 0 initially? Because it is a selection process. Because as also S1 and S0 for 1 1 also we have the data selected, that is D3. Then why should I give for D naught to get? So let's see. If you look at the implementation, then you will get a clear clarity about why should I give 0 0 in order to get a D naught. Okay. If I would like to get D1, I should give the input as a S1, so 0, S0 as 1. So S1 is 0, we have to make it a bar, S1 bar into S0 as it is, as we are having a 1 here, into D1. That is, we got D1, that is output Y, equal to Y. Okay. So 1 means S1 is 0. So in order we made bar. So here we have 1. So 1 into S0, which is already 1 here. So 1 into D1 is D1, which is our output Y. So same as S1 into S0 bar into D2 is equal to Y. And same as S1 into S0 into D3 is equal to Y. Then what is the whole output? The whole output equation, output expression for 4 into 1, 4 cross 1 marks is so S1 bar, S0 bar, D naught plus S1 bar, S0, D1 plus S1 naught, so S1, S0 bar, D2 plus S1, S0, D3, S1, S2, sorry, S0, D3. This is the output expression for the 4 cross 1 marks. Then how to represent? I told you, you will get a clear clarity when you implement that. So how we have to implement? If you see here, we have this in a sum of products. So in sum of products, so what all we have? We have 1, 2, 3, 4. 4 terms that are added, and each term is in multiplication form, right? In order to get the multiplication, we use which gate? AND gate, right? AND gate. Fine. How many AND gates should I use? As I have 1, 2, 3 and 4, I should use 4 AND gates. Then what are the inputs? Of course, S0 and S1. But I should also give one of it to NOT gate. Why should I? Because in some of the terms we have in a notation bar. How we get this bar? By NOT gate. Because NOT gate is for inversion. Okay. Okay. And all these should be given to output, that is our OR gate. We have to add. OR gate, we get Y. We get Y. Okay. If I would like to get D naught as output, what should I do? I should select S0 and S1 as 0, 0. So 0, 0. Let me first draw completely, then I will tell the implementation. So as it is 0 0 for the D naught, for D naught information, so D1, D2 and D3. That is the primary one. First we have to give to each and every AND gate. And then for the selection lines, 0 0 for D naught. So as it is a 0 0, we gave to complements like inverters. So for inverters to inverters, only to inverters I should give to AND gate. And here S1 inverter, S1 to inverter and S is normal. And here S0 to inverter. So S0 to inverter and normal. Yes. And here no inverters because we have 1 1. Yeah. If I would like to get D naught, I should make S1 and S0 as 0 0. Okay, I made 0 0. Then how should I get? I am adding all that. Then how will I get? See. So here 0 0 have given. But here D naught is connected only to inverters. Means 1 1. So D naught into 1 into 1 D naught. Okay. Here if you see D1 into, it is inverter, so 1. Here it is not to inverter, means 0. So D1 into 1, we get D1. But D1 into 0, we get 0. So output of this second AND gate is 0. Okay. Here if you see D2. For D2 here, I am connecting to S1, which is 0. And here it is connected to 1. So D2 into 1, of course D2, but D2 into 0 we have 0. So 0. And then here D3. For D3 I have connected to S1 and S0 directly, not to inverters. So here we have 0 0. So D3 into 0 into 0, we have 0. So here output we get is D0 plus 0 plus 0 plus 0, which is our D0. Hope you got. The same way we get D2 for 0 and 1 of S1 S0 respectively. Means here only these two will get 1 1. In here somewhat 0 we will get, 0 we will get and 0 we will get. So all these three terms will come to 0 and the output will finally become D1. So this is about multiplexer, that is 4 to 1 multiplexer. If I would like to get for 8 to 1, then I should give S2. Then I should give S2, which means another 0 will be added here. For that I have to make again truth table, and so for that on this basis I should make truth table. Means S2 bar, S1 bar into S0 bar into D0. For example, if you see here, so S2 into S1 bar into S0 bar, like that you will get. So how many terms you will get? Totally you will get 8 terms. So 8 terms means you will have 8 AND gates, but only one OR gate, because you would like to get only one output. Hope you understood. Thank you for watching. Please like, share and subscribe.